Okay, so our goal remains to take the derivative of sine and take the derivative of cosine. Let's just do this sort of one at a time. So let's try to tack the sine function first. Now you know how to take the derivative of any function. You can do that via the limit. You take the limit as h approaches 0 of f of x plus h minus f of x over h. That is the definition of the derivative. And now what we're going to do is apply this definition to the sine function to see what comes out. So our function here, the sine function, well, put x plus h into the sine function, you get out sine of x plus h. Put x into the sine function, you get out x. And this is all over h. And then you say, man, how are we going to work with this? Because as h approaches 0, the denominator goes to 0. That already doesn't make mathematical sense. And moreover, h equals 0 upstairs gives you sine x minus x, which would also be 0. Well, as you know, when you have 0 over 0, it just means more work is needed. And to help us in this effort for the more work that is needed, we're going to take this sine of x plus h expression and apply it to the sine of any angle plus any other angle expression. So when we take this sine of x plus h, applying our formula from old school trig, still have the limit as h approaches 0, but sine of x plus h is going to be sine of x cosine of h plus cosine of x sine of h. Nothing fancy, just applying that old formula from trigonometry, and well, we end up where we end up. So then what are we going to do? Well, our goal at this point is sort of to make sense of this seemingly complicated expression. And I'm going to do this in a couple ways. So one, notice there's a sine x associated with this cosine h. There's also a sine x that's being subtracted away. Both of those have a sine x. So I'm going to factor out that sine x. And what remains, you've got a cosine h upstairs. You factored out a sine x from a sine x, which leaves just 1. And that's all divided by h. Note the h is downstairs. It's common among all three of these terms. Even if we think of this as the first term plus the second term plus the third term, all of these are fractions over h. So that term that the terms that we're looking at when we factor out the sine is still going to involve h in the denominator. And then you say, okay, well, we've dealt with the sine x squared cosine h term. That gave us the sine x cosine h. We've dealt with the sine x term. What have we not dealt with? We've not dealt with the cosine x sine h term. So that's that middle term. So to deal with that, that has a cosine in common. I'm going to factor that out. Well, I mean, it has a sine in common as well, but let me factor out the cosine. And when we do, we get sine h over h. So now we've dealt with all three terms above. The first and the last we incorporated into the first expression that we got, and then the middle term into the second. But I want us to take a look at what we have written here. We are taking a limit as h approaches 0 of that whole expression. Now, if you just plug straight in, you'll get h in the denominator to be 0, and that doesn't make mathematical sense. But if you take a step back, you can see something else that's going on. Because inside this parenthesis here, cosine h minus 1 over h as h approaches 0. We dealt with that limit in the previous video. That has a limit of 0. Note what is in the brackets to the right. That is sine h over h. Again, the limit as h approaches 0. We dealt with that as well. That approaches 1. So when you rewrite this, and you incorporate the limit, you now have a sine x, which doesn't involve h at all, so that is just sine x, times 0, plus a cosine x. No, that doesn't involve h either, so as h goes to 0, cosine x is just cosine x. Anything that doesn't involve h is just whatever that anything is. And then that limit, cosine h, is being multiplied by 1. Aha, so what do we have? We have sine x times 0 plus cosine times 1. Well, you know anything times 0 cancels, and then the only thing that's left is cosine x. So the long story short here, after running the whole computation, the derivative of sine is cosine.